Saxon Advanced Mathematics, Lesson 75. Our topic is combinations, which is a spin on permutations, okay? So it's a special kind of permutation. We've already talked about circular permutations, right? Where you put one in the first box. And then we had another one. Permutations where you have, what were they called? Discernible permutations. That was where like the letters in the word moo, where you have two O's, and so it doesn't make a difference if it's the first O or the second O. You remember what I'm talking about. Combinations are kind of like that. They're a special case permutation, and they're illustrated well by choosing people for a committee. Let's say, as we're going to say in our example, that there are 12 students who want to be on student council, and there are 5 different positions in student council, right? There's going to be 5 office holders, if you will, chosen from these 12 students. Well, it doesn't matter what order we choose them in, because once they're elected, then, or chosen, it doesn't matter anymore what order they in. So that is a combination, is a permutation where order doesn't matter. And the way that we calculate it, I'm going to show you a formula, but I want to show you with words first. What you do to find the combination, first you find the permutations, and then you divide it by the number of things. Is that right? No. Take an R at a time. It should be an R. N things R at a time. That's our code, right? Let me show you how this works, and then this will actually make some sense to you. Okay, example 75.1, because right now it's too abstract and you don't know what I'm talking about. In how many ways can a committee of 5 students be selected from a group of 12 students? So the first thing we do is we find the number of permutations. I have to break down and buy another green marker, you guys, and I haven't gotten around to it. And it's stressing me out because this one is getting so worn. Okay, so we're selecting a group of 5 from a group of 12. So for the first chair, if you will, we have 12 to choose from, then 11, then 10, then 9, then 8. Okay? That's the number of permutations. But we have to divide that by the number that we're choosing, R. That number factorial. What that essentially does is it accounts for the fact that we don't care what order they're in, okay? 5, I don't want to drag you down into the theory of that, all right? You can just trust me that by dividing by the number of things, the number at a time that we're choosing, like 5 students, we divide by the factorial of that, and life is much better. So 5 and 2 can cancel the 10, 4 and 3 can cancel the 12, and we get 72 times 11. So there are 792 different ways. There are 792 different combinations of 5 students that we can pick from the 12 that would serve on this committee, and that doesn't have anything to do with what order they're chosen in, right? I'm trying to decide if I want to tell you this next thing. I think not yet. There's 2 more examples. And I didn't write this step 2. Okay. So this is a little simple formula for what we did here. You find the number of permutations, and then you divide it by the number at a time that you were choosing. In this case, it was 5 factorial. All right. So if that helps you, good. Let's try another one. 75.2. There are, oh, and here's a little picture. I'll just show it to you. I won't copy it. There are 7 points located on a circle as shown. How many different triangles can be drawn by using these points as vertices? Okay, well, a triangle requires 3 vertices, right? So we're going to need 3 points for every triangle. So there are 7 points, and we're choosing them 3 at a time. So in the code, n equals 7 and r equals 3. Okay? But we can draw out our box, because this always makes it seem more logical to me. We can choose any one of the points to start at, then choose from the others, then choose from the others, but we have to divide this by the factorial of 3. So we have to divide it by 3 times 2 times 1. Makes sense? 3 times 2 cancels the 6, so that means there's 35 triangles that we could draw. Interesting, right? I mean, as much as theoretical problems about drawing problems can be interesting, I think that's interesting. Okay, one more. And then I'll tell you that thing I was trying to debate if I should tell you yet. I want to make sure you get the practical rhythm of how to solve the problem before I start telling you weird mathematical tidbits. 75.3. Whoops. How many different 5-card hands can be dealt from a deck that contains 52 cards? I wrote this on the top because this is what this is the n things taken r at a time. This one is the n and this one is the r, right? The r is the group that we're calculating, and that matches to the box that we draw. All right, so that means 52. Ooh, these are big numbers, right? And we're going to divide that by 5 factorial. 5, 4, 3, 2, 1. We're not going to do the math on this in our heads because look at the number. 2,598,960. That's a really big number. You don't have to use your brain to do that. Okay? That's a lot. So, yeah, John says we recommend the use of a calculator for calculations like this one. I should think so. No, I don't want to talk about that other thing that I told you about. I just want to show you that the formula for combinations of n things taken r at a time you take the number of permutations of n things taken r at a time, and you divide by r factorial. That's what we did here and in the other problems. But if you want to take this part of it and blow that out into a formula, we write that as, let me make sure I copy this properly. Yes. That's the formula for a permutation of n things taken r at a time. We've had that before. And so we just add to that little r factorial right here. Okay, so the permutation of n things taken r at a time is n factorial over n minus r factorial. So we can take this formula and merge them, and here is like a comprehensive formula for combinations. I personally don't find that really useful. I think this way is better because I can remember how to do the basic permutations and then just divide it by that number of things. But this looks like too much drama for me. But whatever helps, right? Okay, that is lesson 75. Those are called combinations. And once again, a combination is a permutation in which order doesn't matter, like choosing people to be on a committee or dealing cards out for your hand. Once you pick up those cards, you can put them in any order you want, right? You don't have to keep them in the order they were dealt. Okay, that was a fun one. I enjoyed it thoroughly. I hope you feel smart. Thank you. Goodbye.